Thank you, Snan. Now I will tell you heating the celery in a rotary kiln. Raw meal or celery prepared as above is introduced into the rotary kiln with the help of a conveyor. The rotary kiln consists of a large cylinder 8 to 15 feet in diameter and 300 to 500 feet in length. It is made of steel and is lined inside with fire bricks. The kiln rotates horizontally on its axis at the rate of 1 to 2 revolutions per minute, and it is inclined a few degrees. As the kiln rotates, the charge slowly moves downward due to the rotary motion. Now the charge is heated by burning coal, oil or natural gas. In the rotary kiln, the charge passes through the different zones of temperature where different reactions take place. The charge takes 2 to 3 hours to complete the journey in the kiln. There are 4 zones of temperature in the rotary kiln. First is drying or preheating zone, second decomposition zone, third burning zone, and fourth last one cooling zone. Drying or preheating zone. It is minimum temperature zone. In this zone the temperature is kept at 500 centigrade, whereby the moisture is removed and the clay is broken into aluminum oxide, silicon oxide and ferric oxide. Decomposition zone. It is moderate temperature zone. Here the temperature goes up to 800 centigrade. In this zone the limestone decomposes into lime and carbon dioxide. Burning zone. It is maximum temperature zone. In this zone the temperature goes up to 1500 centigrade and the oxides formed, calcium oxide, cesium oxide, aluminum oxide and ferric oxides combine together and form calcium silicate, calcium aluminate and calcium ferrite. Functions of tricalcium silicate. It hardens rapidly and largely responsible for initial set and early strength. The increase in percentage of this compound will cause the early strength of Portland cement to be higher. A bigger percentage of tricalcium silicate compound will produce higher heat of hydration and accounts for faster gain in strength. Functions of tricalcium aluminate. It contributes to strength development in the first few days because it is the first compound to hydrate. It turns out higher heat of hydration and contributes to faster gain in strength, but it results in poor sulfate resistance and increase the volumetric shrinkage upon drying. Cement with a low tricalcium aluminate contents usually generate less heat, so develop higher strength and show great resistance to sulfate attacks. It has high heat generation and reactive with the soils and water, containing moderate to high sulfate concentration, so it's least desirable. Function of tricalcium aluminoferrite. It assists in the manufacture of Portland cement by allowing lower clinker temperature. It also acts as a filler. It contributes very little strength of concrete even though it hydrates very rapidly. Also responsible for grey color of ordinary Portland cement. Cooling zone. This is the last stage in the kiln where the change in temperature is 150 to 200 centigrade. Clinker formation. The resulting product obtained from the kiln is known as cement clinker. This has the appearance of greenish black or grey colored balls, varying in size from small nuts to peas, as shown in figure. Grinding the clinker with gypsum. The cement clinkers are then air cooled. The required amount of gypsum 5% is first ground to a fine powder and then mixed with clinker. At this stage finished cement is pumped pneumatically to storage silos from where it is drawn for packing in paper bags or for dispatch in bulk containers. In this figure, it is shown when gypsum and clinkers are ground. In this, when it is completely ground, then cement is formed and it is sent to silos. Now I will tell you about setting of cement. The use of cement in the construction of building is based on its property of setting to a hard mass when it's spaced with water is allowed to stand for some time. The reaction involved in the setting of cement are described as follows. Reaction taking place in 24 hours. A short time after the cement is mixed with water, tricalcium aluminate absorbs water and forms a colloidal gel of the composition 3CaO Al2O3 6H2O. It is hydrated tricalcium aluminate. This gel starts crystallizing slowly, reacts with gypsum to form the crystal of calcium sulfoaluminate. Reaction taking place between 1 to 7 days. Tricalcium silicate and tricalcium aluminate get hydrolyzed to produce calcium hydroxide and aluminum hydroxide. The calcium hydroxide thus formed starts changing into needle-shaped crystals which get studded in the colloidal gel and imparts strength to it. Aluminum hydroxide on the other hand fills the interstices resulting in hardening the mass. The gel formed starts losing water partly by evaporation and sets to a hard mass. This is all about production of cement. Now thanks.